So today we're just going to have a look at this Champion log splitter. I'm going to operate it and talk about how it functions, but we'll do a quick walk around first. I'll show you what's part of the machine and what modifications I've made for testing here. So this is a 22-ton log splitter. It's a 92221 model Champion, which we only use for training purposes. It's got a 196 cc engine. They don't give a horsepower rating on this, but from my calculations I think this is going to be probably an 8 or 9 horsepower engine. Single cylinder gasoline 4-stroke. It seems to rev out to about 4,000 rpm. I don't have a tach on it, but we'll use our ears when we're talking about rpm and horsepower load, etc. Directly coupled to it, under here there's a coupling coming right off the crankshaft. We've got our 2-stage gear pump, very similar to the one in our other video. Just has aluminum housings for these two sections connected to a cast iron one at the drive end, rather than all three being cast iron like the pump I disassemble in the other video and show all the parts. But same thing, large volume gears for low pressure only, small volume gears for high pressure, and of course both flows combine at low pressure to come out the discharge line here. We've got our unloading valve under this cap. We've got a suction line coming in here from the tank. So from the tank we're drawing oil into the pump through a nice clear hose. Flow from either one or two pumps, depending on the pressure, is going to exit out this discharge line, which is a 36 megapascal hose. Runs up to the control valve. Now, one of the modifications I've got in here for testing, I've got our flow meter in here with the load valve on it. So we've got a flow meter. We're going to look at pressure and flow on these indicators for the test. Then after the flow meter, I'm going into my directional control valve. So the DCV spring-centered cap, spring-centered DCV, and that extends the cylinder, retracts the cylinder, and then if I don't have any pressure load, I can detent it into a locked position, and when it's in that position it will retract the cylinder automatically, and then when we get the pressure spike when the cylinder hits the end of its travel, that pressure spike within the DCV will kick the plunger here on the end back to the hold position. So that's our DCV. Only one section in there, one spool. Coming out of the DCV, we got some more modifications with quick connectors here that wouldn't normally be there. We're in low pressure out of the DCV back to the tank, so we can see some low pressure type fittings and hose clamps even. And then the return hose goes back. The only restriction back to the tank, a full flow filter, spin-on element there, back into the reservoir. Reservoir, you know, by mobile hydraulic engineering standards, very undersized. You know, it's only got a few, maybe 4 or 5 gallons in there. We've got a pump that can put out about 14 gallons a minute. So in typical mobile hydraulic engineering, we'd want that tank to be at least double that 14. We sure don't have any 28-gallon tank there, so not surprising if this oil is going to heat up rather quickly and stay fairly hot while the machine's running. But we're not always going at 14 gallons a minute, and certainly not under load all the time. But the walls of the tank are the cooling. There's no oil cooler on this. We're just relying on the walls of that tank for cooling. There's a sight glass on there so we can see the fluid level as well as the clear suction line. And cap for filling, which is vented. And that's basically the system. It's an open center directional control valve. So when we have the control valve in the hold position or neutral position, should make it fairly easy to pull start this machine and get the engine running. If you can't pull the engine over, you might want to check and make sure that you're not in the retraction detent or something goofy like that. But if we're in the neutral position as we are, we got oil in the reservoir, should be okay to start this. And I'm just going to start it at low idle, and we'll have a look at the flow meter and see what it shows us for flow. So low idle, it's like we got about 20 liters a minute, 5 gallons per minute. A little better than 5. So again, I was talking about 14 gallons a minute, but that would be at high idle because the engine's turning very slowly and it's a fixed displacement gear pump. We don't have a whole bunch of flow. Pressure basically shows 0, although 0 on this pressure gauge is really a couple hundred psi. This gauge, which has been added at the pump outlet, also agrees with that there's really no pressure in the system. So there's 5 gallons per minute of flow at low idle going through the flow meter, through the directional control valve, back to the reservoir, being picked up by the pump, and we just be circulating like that for as long as we leave the machine running. I'll take it to high idle and we'll see what happens to the flow. So we've gone up to about 16 gallons a minute at high idle. And that's again fixed displacement pump. You turn it faster, multiply the RPM times the displacement, you're going to get that higher flow rate. And that is with the control valve in neutral, and the load valve is wide open on this flow meter. So there's no restriction to flow. We're just looking at the flow, no pressure, even at high idle. I'm going to start to restrict the flow with the load valve, and we'll watch what happens and listen. What I did there twice is I was tightening the load valve in, and what you could see happening was the pressure was coming up 200, 300, 400, 500 psi. As the pressure was building, first thing we notice is the engine starts to lug because it's a fixed displacement pump. 14 gallons a minute it was putting out at high idle, or actually about 16. And then we're putting the pressure up. Pressure times flow is the multiple that gives us our horsepower load. We start asking that engine for a lot of horsepower. It doesn't have a lot of horsepower, so the engine RPM start to lug naturally. And then as I come at it with higher pressure, all of a sudden the engine revved back up. And the flow stayed low, but the pressure started to drop back a little bit, or it maintained the pressure, but you could hear the engine rev right up. The reason the engine started to rev up is because the unloading valve did its job. The unloading valve kicked in and started to dump the flow from the large volume gears. Instead of putting that flow out the discharge with the small volume gears, it started to dump that flow back to the suction side of the pump. So this unloading valve, somewhere around 600-700 psi, maybe 800 psi, I wasn't watching that carefully, but maybe it was even up close to 1,000. Once we got to that pressure, the unloading valve opened and recirculated that flow back to the suction side. Then the load came off the engine. We still had a couple of gallons a minute or a few gallons per minute flowing because the small gears can't unload. They keep sending their flow out, and we go to basically a very small gear pump. Well, with that very small amount of flow times the higher pressures, we don't lug the engine anymore. We're asking the engine for much less horsepower. So again, the mathematical equation of pressure times flow. If you've got PSI and GPM, you multiply those out, you divide it by our constant of 1714, and that will tell you basically the horsepower demand on the shaft of the pump. It's hydraulic horsepower load, and then with the inefficiency, the engine's got to pump the oil to that pressure, plus pump any internal leakage. So we're asking the engine for probably 15-20% more power than that math gives us. So the engine's very limited because of its displacement. It's not a high torque engine. It doesn't give us a lot of power. So it starts to lug down, and then it would lug down right to stall out if we didn't have that unloading valve. But because the unloading valve kicks in, then we can continue to work at higher pressures. I could keep winding that load valve in. I don't want to because I don't have a relief valve between the pump and the load valve of the flow meter. But as we'll see, we can operate this machine right up to several thousand PSI. I'm going to back the load valve out. We'll just see what kind of maximum pressure we can operate at by using the cylinder. And I'm not trying to be a compliance geek with these wheel chocks, but you may have noticed this machine vibrates a lot, and on the smooth floor here it likes to dance around, so just trying to keep it where we want it. So you can see what was happening there. We could have high flow at low pressure. We can have high pressure right up to the main relief, looked like it said about 3,300 psi. We could have that high pressure, but never could we have high pressure and high flow at the same time. By the time we get up there, and you can see if you feather the control back and forth, you can really hear and see the unloading valve doing its job. The engine goes under fairly extreme load, kind of squawks and grunts a little bit there because it doesn't like the load, and then once the unloading valve kicks out, then the pressure will start to climb, but the flow will stay very low. So that's the unloading valve doing its job. If you need to adjust that unloading valve, pretty simple process. All we need is a wrench and a screwdriver. So make sure the switch is off, and we can take the cap off here. The cap is the lock for the setting. I'll just back back this unloading valve out a bunch of turns. See if I can do this with one hand while I hold the camera with the other. Don't look too skilled with a screwdriver when it's oily. Take it out about 3 turns. And I'll put the cap back on. So what I've really done it now is super weakened that spring on the unloading valve. So it's going to unload now at very low pressure. What that's going to do is make the engine quite happy, because the engine's not going to have to fight very much load anymore. As soon as the pressure starts to increase, the unloading valve is going to kick in almost immediately. So the engine's loving that. You notice as I loaded up the load valve, the engine never really went under that heavy load, never squawked and groaned or complained. And everything still seemed to function well. We could still get our main relief pressure, 3,300 psi. It didn't seem to be it seemed to be unaffected until we put a lug in there and try and split it. And then we're going to find out that even the softest wood, it's going to be painfully slow, because as soon as the pressure comes up even 150, 200 psi, the unloading valve kicks in. We can't have any flow at any pressure or any high flow. The flow cuts right back to very low volumes as soon as it goes under any kind of load. So we'll save a lot of fuel, and the engine will live forever with this current adjustment I've made, but the performance of the machine is going to be compromised. So we'll want to have that unloading valve adjusted in to spec. It's not as on-off like the switch that you'd see described as the function of an unloading valve. When an unloading valve is described, usually they talk about it, maintaining 2-pump flow, or both sections of the pump flowing oil until you hit this magic pressure, and then snap, the large volume section kicks out. Well, as we saw, it's a very gradual. As you increase the load, the needle on the flow meter comes back really very smooth and analog, because the unloading valve isn't an on-off switch. It isn't pilot operated. It's a spring and a poppet, and that poppet starts to compress the spring, and then the full open setting is somewhat higher. So it is almost taking a 2-stage fixed displacement pump and making it act like a variable displacement pump. If I go the other way on the adjustment, I'm just going to pause this so I can make the adjustment, and I'm going to crank it right in. I'm going to go back in that 3 turns and then a couple more. Okay, so I've wound that unloading valve in. Wasn't many threads sticking out when I was done. I cranked it in about 5 full turns. So I'll make sure the unloading valve's open here. Start back up. The unloading valve, I got it in so tight now that it is not unloading. We're running out of engine power. The engine's not happy at all. So we're asking the engine to keep giving us high flow at high pressure. Mathematically, that equates to more horsepower than that little engine has. So then naturally the engine lugs down and stalls out. So that's the symptom of a unloading valve that's been adjusted in too far. So hopefully that gives you an overview of that system as it operates, as it pertains to a log splitter with a 2-stage fixed displacement pump.